So this is the walkthrough of the review for the G quiz on Empirical Rule and Z-scores. So the first part we have is we have both sides. One is commute time from Round Rock to Austin, and that one has a mean of 45 minutes and a standard deviation of 1.8 minutes. So that's important information to know, all right? And then we also have duck eggs with a mean of 2.5 ounces and a standard deviation of 0.2 ounces, all right? Mrs. Perry used to teach at Cedar Ridge, no longer teaching at Cedar Ridge, doing other things. All right, so, and I'm pretty sure I don't need that mark right there, whatever the heck. I guess it's stuck there. Must be scanned in. Okay, so clearly label this unstandardized model using the empirical rule. So one thing I'm going to do, I'm actually going to open up the unit packet. We'll do it for second period, should be fine. And one of the things I covered on the G2 notes, which we'll get there, give me a second. We were doing, so G1 notes is Z-scores, and we did this in class. And then this is practice. Don't forget you got the solutions on the Z-scores there. So here was the normal distribution in the empirical rule. So this should have been around page 10 of your packet. So I pretty much copied this graph. You want it on your cheat sheet for your test. You want to have this page folded if you're taking the quiz, and you can refer to this. So this has a lot of the information, especially if you copy those little areas down on it. All right, so let me go back to the quiz review. So what we did is, instead of me copying and filling in the slices, which probably is the better way to do it, I had the areas written down underneath. So the areas are between the sections. So first, when you decide your first section, you are going to, I guess I don't want to do that. You are going to put your mean in the middle. So we put 45 here, and we put 2.5 ounces there, all right? And then next thing you do is you go step up by one standard deviation. So 45 plus 1.8 is 46.8. If I add another 1.8, we get 48.6. If I add another 1.8, we get 50.4. All right. And then you can also step down, subtracting 1.8 to get all 7 numbers, really, that you want on the dividing lines, okay? And the same thing here, we have 2.5, standard deviations 0.2, so we just go up by 0.2, and then we go down by 0.2, starting with the mean. Now, if you have these little areas here, or you have them drawn like that, which is probably easier to understand, then the next few questions with the empirical rule are pretty easy. So if we're looking at 43.2 to 46.8, that's from here to here. So that's a 34% piece and a 34% piece. We get 68%. If we look from 2.3 to 2.9, we're going to have from here to here is 34%. You see it right there. Plus another 34% plus 13.5%. That gives you 81.5%. All right, what percent of the days does the trip take less than 46.8 minutes? So there are a couple ways you could do this. One you could realize is that this first section that I have highlighted is half the area, so that's 50%. And then we just need to add this one little extra piece here, which is 34%, and I get 84. Now, if you're more comfortable, you can actually just say, okay, I need to add everything that's in front of the 46.8. So you have 0.15, 2.35, 13.5, 34, and 34, and you're going to get the same answer. Okay, what percent of eggs weigh less than 2.1 ounces? So this is only 2 sections that I've highlighted right here. So the first piece is 0.15, and the next piece is 2.35%. Add those up, and you have 2.5%. Okay, last empirical rule question. What percent of days does the trip take more than 41.4 minutes? So that's starting here. So if I were to highlight that, let me go ahead and do a different color. Okay, more than 41.4. So that means I need to add all these pieces right there. So I'm going to, I could go 12.5 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. Or I could make my life a little bit easier and say, hey, just take 100% and subtract those two pieces, which is the work I showed here. Either one works. Over here, we wanted more than 2.9 ounces, so that's just the last two pieces. That's not a lot to do, so we just add those and we get 2.5%. Now, one of the formulas you definitely want to write down on your cheat sheet is the Z-score formula. So Z equals your value minus your mean divided by standard deviation. So our value, what is the Z-score for a day when the trip took 42 minutes? 42 is the value, and the mean we already had up here. Remember, that was 45, and our standard deviation is 1.8. Same thing over here. We're going to use a 2.5 and 0.2 for that problem. So there's 42 minus 45 divided by 1.8. And you get negative 1.6, etc. All right. Z-score for an egg that weighs 2.2 ounces. So you put the 2.2 in the value. You put the mean from above, which we said was 2.5, and the standard deviation of 0.2, and you get negative 1.5. Okay, now here's another formula you're going to definitely want to memorize, and that is value equals mean plus your Z-score times the standard deviation. So make sure you memorize that formula. So you need this one right here, and you need that one right. That's the same formula, really. So you need these two formulas right here. So we have the mean, we have the Z-score, and we have the standard deviation. Multiply these two first, and add the 45, and you get the right answer. All right. So here the Z-score was 2.4, our standard deviation is 0.2, and then use your mean. On to the next page. So now we have two cars that are being compared. We have the Ford Escape, and the data is they get 28 miles per gallon. And then we have, I'm going to switch colors for the Ford Fusion so we don't get too confused. They get 31 miles per gallon, all right? The mean fuel efficiency for all sport utility vehicles, so that's the yellow, is 32, so the mean is 32, and a standard deviation is 7.6. For the mid-size sedans, the mean is 27, and a standard deviation of 5.2. So what you're doing is you're calculating Z-scores based on the two different distributions, right? So same thing over here. If I went to this right side, well, let me go ahead. So the Z-score for the Ford Escape, that's our yellow, is 28 minus 23 divided by 7.6, and we get 0.658. The Z-score for the Fusion is 31 minus 27 over 5.2, and we get 0.769. So the Ford Fusion is actually a little higher than average compared to the Escape because of their Z-score. So you would pick that one because of the higher Z-score. Now over here, let's go ahead, and we have the mean height of men is 69 inches, all right? And a standard deviation is 3. For women, the mean is 64 inches, all right, and standard deviation is 2.2 inches. The tallest woman in the Women's National Basketball Association is Brittany Griner, so she's 80 inches tall, 6 foot 8 inches. And the tallest male player is Hashim Tabit, who is 87 inches tall. That's 7 feet 5 inches. Which player is taller relative to the others of the same sex? So show your calculations. So we're basically, for our yellow, we're going to take that value of 87 minus the 69 divided by 3. Make sure to use a good calculator, because if you go 87 minus 69 divided by 3, you might get a wildly different answer. And then Brittany Griner, we have 80 minus 64 divided by 2.7, so that's 5.93. And it turns out that Hashim is slightly more unusually taller. Not much, but slightly more unusual than Brittany Griner. Okay, so now let's go on to this next bit. I know some of you had trouble with this one. And let's go ahead and get to work on that. So we have red blood cell count in millions per cubic feet. So we've got females over here on this side, and the mean is 4.8, and the standard deviation is 0.3. And then for the males, So males, the mean is 5.4 and a standard deviation of 0.35. All right. So convert the following X interval to a Z interval. So what they mean for you to do, let me just move this out of the way a little bit, is they want you to change X to a Z. All right. So we do a Z-score formula, and then I just rewrite the interval. Instead of writing an X, I do a Z, and then I put in the Z-score instead of the X value. All right. So you can see that basically right here, that kind of just goes down there. All right. So you have the same direction and everything, except instead of an X, you have a Z. And if you have two of these, you would just calculate two values. So if it was like X is between 3.2 and 5.3, for example, you would just do the Z-score for 3.2 as well. All right. On the same side over here, we're going to calculate the Z-score for 6.2, which is 2.229. So then again, I just switch X with Z, keep the same direction, and put the Z-score instead of the X-score in there. Convert the following Z interval to an X interval. So then you want this formula right here, which we used on the previous page. Value equals mean plus standard deviation. Mean plus standard deviation times Z. So we substitute in the mean. We did have the mean up here. It's 4.8, so there it is. We put in the Z-score, and we put in the standard deviation, and just use the calculator. We calculated 4.05, so we put that in instead of the Z-score, and we replace the Z with X. Same thing over here, 5.4 plus negative 2.2 times 0.35, and we get 4.63, so we just substitute in there. If a female has 3.8 million per cubic millimeter RBC count, you say it's unusually low. Best way to do it is to calculate a Z-score, and we got negative 3.33. So anything less than, now let me do a slight typo, anything less than negative 2, all right, is unusual, and anything more than positive 2 is unusual, all right? So that's basically your answer. That's also your answer for 11, by the way, which is the same thing. So if you are more than 2 standard deviations away from the mean, so if you're in this area out here or in that area out there, that is considered unusual. And hopefully that should be enough to help you with your quiz.